Today's video is titled 11-5, the volume of prisms and cylinders. What I'd like you to do is right underneath your daily agenda to draw a line and then split it up 3 ways equally so you have 3 equal rows, and we're going to draw some pictures at the top. We're going to start off with this idea of slicing it up. If I took this rectangular prism, this cylinder, or this triangular prism, and I started to cut out pieces of it, what shape would a cross-section be? So I'm going to go ahead and take a red pen here, and I'm going to draw what would be a cross-section. What shape would that be? Well, if this is a rectangular prism, then one of the cross-sections would be a rectangle. How about a cross-section of a cylinder? I'll take one from up here. It would be a circle. Or a cross-section of a triangular prism. Not a very good picture here, but you get my idea. It's a triangle. The cross-section is basically a congruent image, a congruent shape to the base. So if the base is a rectangle, a cross-section would be a rectangle. What does this have to do with volume? Well, the idea of volume is asking how much can fill up this entire space here. So I want you to imagine that you have this area, and then I take a cross-section right above it. There's another area, and then I take the cross-section right above it, and right above that one. I'm going to pick another color here. Okay, and there's another cross-section. And now I'm going to draw in another cross-section. Now, if these cross-sections were very, very close to one another, like pieces of paper piled on top of each other, those areas would fill up the entire space. That would be the volume of that prism. And that's where the formula for the volume of a prism comes from. So here's the formula. I'm going to put it in a box. The volume of a prism, and we call that the letter V, it's the area of the base so that's the area of this base, or this base, or a cross-section, times how tall it is. The abbreviation would be the area of the base times the height. But remember, the H is how tall. And that makes sense looking at the cross-sections, especially in this section right here. So let's suppose in example 1 that you're at the San Diego Zoo and you see a polar bear with this chew toy. And I were to ask you to find the volume, or how much material is inside of this chew toy. Well, the first thing I'd want you to do is know the dimensions of it. So I'd like you to go ahead and draw this cylinder. It has a diameter of 6 centimeters and a height of 8 centimeters. They asked me to find the volume, and I know immediately that the volume is the area of the base times the height. So I'm going to start first by finding the area of the base, area of the base, and second, I'm going to go ahead and plug that into my volume formula. So I'm going to color code this. So first I'm in red. I'm going to find the area of the base, which happens to be a circle. The area of a circle is pi times radius squared. Now in this case, the radius isn't 6, it's half of this amount, so it must be 3. That means since they asked me to leave it in terms of pi, it's 9 pi centimeters squared. Now my last part is to just plug this into the volume formula. So the volume is the area of the base, 9 pi centimeters squared, times the height, which is 8 centimeters. And I want you to notice that I have centimeters and centimeters squared right here. Centimeters squared and centimeters. My volume is going to be 9 times 8, so 72 pi centimeters. There are 2 here, 1 there, centimeters cubed. Volume is cubic, so please make sure that every time that you put a volume down that you're that your amount is always cubic. Okay, let's look at example 2. This time they've given you a triangular prism. It has bases of triangles, and it has 2 bases, so it's a triangular prism, and they're asking me to find the volume. So again, I know my volume formula is the area of the base times the height, and I know that I'm first going to find the area of the base, and my second step is to just plug it into my volume formula. Okay, so again, I'm going to color code. So the first thing I'd like to do is find the area of the base. So I'm going to do that math right here. So my base is a triangle. Oops, sorry. My base is a triangle. So that will be the base of the triangle times the height of the triangle divided by 2. Now just to make sure you know what the triangle I'm looking at, it's right here. Now I can clearly see that the base is 5, but I do not know what the height is. But as you may have noticed, if I have 2 matching bases, if it says the hypotenuse is 8 here, then it's 8 centimeters here too. That means I can use the Pythagorean theorem to find the height. So I'm going to do that. Here's what I get. Okay, so I get h squared plus 5 squared equals 8 squared. So that's 25 and a 64. If I subtract 25 from both sides, I'm going to get 39. So that means that h is the square root of 39. Now 39 is just 3 times 13. So there's no pairs there. So my height, unfortunately, is just this radical. That means if my base is 5 and my height is the square root of 39, and I take that product and divide by 2, since I can't simplify it, that is the area of my base. And of course, let me move this over just a little so I can put my units. That is meters squared. Let me get that in there. I'm going to erase this line. Oh, it won't let me do it. Let me see if I can squeeze it in there. Meters squared. There you go. Okay, now that I found my area of my base, now I can go to my step 2. So the volume is the area of the base, 5 times the square root of 39 divided by 2, times how tall is this shape? Well, it's 25 meters tall. Now remember, my area of my base is meters squared and my height is meters. That means even if I don't know how to do this math, I know that my answer is going to be meters cubed. All right, I'm going to multiply my numbers in the top, so my numerators. 5 times 25 is 125 times the square root of 39 divided by 2. And that is the volume of my triangular prism. For example 3, I'm going to start you off on this word problem and you're going to finish it on your own. Here's what it says. Example 3, find the water capacity of the aquarium. Round to the nearest whole number. And what they're looking for is how much water fits into this section where the fish are. They're not looking for any of this part, just the part that fills in the water. So I'm going to pull this to the side so you kind of have this here. And let's kind of analyze this. When they ask you for the water capacity, what are they really asking you for? They want to know how much water fits in this curved section right here, or really, what's the volume of that shape? So water capacity is the same kind of question as asking what's the volume. Now over here on the left I have kind of a picture of this water section without all the fish inside it. And I've put in the measurements here. So the diameter is 24 inches and you have a height of 12 inches. So let's kind of go over what our steps might be. We know that we're looking for the volume, so I can go ahead and say that's going to be the area of the base times the height. And I know my steps because of what we've done in the past. I'm going to start off by finding the area of the base. Area of the base, which is B, right? And the second thing I'm going to do is I'm going to plug it into my formula. But I'm going to go ahead and suggest that there's a third step. So let's think about this. If you do just these first two steps, you're really finding the volume of an entire cylinder, a whole cylinder. But when I look at this picture, this is clearly not an entire cylinder. So I'm going to leave this third step blank, and when I check your notes, I'm going to be looking for two things. I'm going to be looking for the water capacity of the aquarium, and also for you to have filled out this third step for this problem. Good luck.